Hello, right. Today I want to look at recapping and going over calculations to do with area and density, and I thought I'd use a little bit of topical information from where we are at the moment. So I'm going to look at it in relation to politics and then compare it and contrast it to what's happening in schools. So, learning objectives today, first of all, we're going to recap some basic formula. We're going to apply that to simple shapes and then recap density terms related to area, and then do a little bit of comparing and contrasting and finishing off with some extension tasks for you to take away and do on your own later. So this is the first task I thought I'd look at, looking at a simple shape. So this is the House of Commons chamber. The House of Parliament have decided they can go back, that it's safe for them to do so long as they observe social distancing. And so this is the example I want to take for this, because we all know that we've got to be 2 meters away from everybody else. And so from this is the House of Commons chamber. This is where MPs sit. Now there's normally a few hundred of them. And what I want to do first of all is look at this picture. Can you tell me what the floor plan is? If we're looking down from above, we're looking down on top of this, what kind of basic shape have we got as the floor plan? Now, when I ask these questions, you should pause the video, think about what your answer is, and then come back to see whether or not you got it right. So in this case, it's a rectangle. Looking down from on top, we have a very simple rectangle. And the House of Commons is 21 meters long and 14 meters wide. So my next question, of course, is what is the area of this rectangle? So to find the area, we first of all need to know the formula. And this is a recap. You should know this. You should remember it. What is the formula for the area of a rectangle? Again, I've asked a question, so pause the video, come up with your answer, and then come back and check if it's okay. So that's length times width. Well done if you said that. Width times length, length times width. Absolutely fine either way around, because multiplication is commutative. You can do 2 times 3 equals 3 times 2. It's the same whichever way you do it. So what is the area of this rectangle? Another question. Pause the video. And we're back. 21 times 14. The answer is 294. But what have I forgotten? What's one of those things I keep telling people that I must remember to always add when we're talking about area? Pause. It's the units. We've got to use the units when we give calculations and measurements. So that is square meters, written with an M with a little 2. And looking at that, we can say, well, how do we get that? Just a recap for those of you who were a little bit unsure how we work that out. In square meters, each square is a meter by a meter. And so I can fit 21 across like this. And as we go down the line, we can fit more and more and more until we've got 14 rows of 21, which is why we do 14 times 21. So that was just a quick recap of where we are there. Now, in terms of social distancing and looking at density, that gives us 294 square meters. The MPs have decided that they're only going to allow 50 people in this chamber at a time. So 50 people means that they should be able to maintain their social distancing. So long as they behave like adults and all make sure they take their turns and be aware of what's going on around them, should be no problem whatsoever. So what is the density? Again, pause and come back to me in a minute. Is it the number of MPs divided by the area, or is it the area divided by the number of MPs? Give that some thought. Now, really give this some thought. Actually, the answer is either. But the units will change. Just as I said that units for area are important, we mustn't forget them, square meters. In this case, you can do the density either way round. You can have the MPs per square meter. How many MPs can you fit inside 1 square meter? Hopefully that will be less than 1, bearing in mind that everybody's got to be 2 meters apart. So we should have less than 1 MP in a square meter. Or you can do it the other way around and say, how many square meters per MP? Almost like how much do they own? How many square meters belong to that MP? Okay, so let's have a quick look at that in terms of calculations. So MPs divided by area, 50 divided by 294. As I said, below 1, 0.17 MPs per square meter, rounded to 2 decimal places. Always remember when you put rounding, to put that 2dp in brackets afterwards to make it clear that's what you've done. Or the other calculation is how many meters per MP. So 294 divided by the 50 MPs gives us 5.88 square meters for each MP. Why didn't I put it in brackets? Why haven't I put the 2dp? Well, you do the calculation for yourself and see if you can figure that one out, and you can tell me later. So, giving you a visual idea of what that looks like, if each MP has 5.88 meters, virtually 6 square meters each, this is the sort of density we'd be looking at in the chamber, in terms of how many MPs where they'd have to sit to make sure. And you can see generally we can probably see that they're going to be about 2 meters apart. So now we're going to compare that to a standard UK classroom. Now these numbers come from the government guidelines on what is a standard UK classroom. You can have larger classrooms if you've got scientific benches, if you've got a workshop, if you've got other little things. But the standard UK everyday ordinary classroom, tables, chairs, whiteboard, etc., 55 square meters. So I'm going to make that a little bit easier because, well, most of us are rectangles, and I don't want a 5 meter by 11 meter room. I'm going for an 8 by 7, a square-ish room, and that gives us, of course, 56 square meters. 8 times 7, 56. So if we use the figure for MPs, this is a question for you. How many school children can fit into this classroom? So pause it, work that one out. Remember the figure for the MPs was each MP has 5.88 square meters. So if you've worked out it's the area divided by the square meters per MP, you're right, and you're on the right line, good. So that's 56, the area of this classroom, divided by 5.88, which equals 9.52, put in brackets 2 decimal places, children. No, you forgot the teacher, didn't you? So the teacher's got to go in the classroom as well. So that's not 9.52 children, it's 8.52 children. And although there may be the odd child in my class, you know who you are, who I might like to be the 0.5, it's not really acceptable to chop a child in half just to make us fit into a classroom. So we're going to call that 8 children. 8 children, 1 teacher, 9 people in a classroom. There we go. So then we come to our extension activities. Each person, bearing in mind these are the premises of what we started with, each person has a personal space of 1 meter in any direction. Yeah, so 1 meter that way, 1 meter. But the other person has 1 meter as well, so that their meters can't touch. So you can see here we've got the circles with a red cross on. Essentially we're saying we mustn't overlap, because that means that everybody then is 2 meters apart. So each circle has a radius of 1 meter. What I want you to do is to discuss, so I want you to explain and write your answers as a sentence, as a paragraph, with appropriate calculations, how many people can fit in an 8 meter by 7 meter room. Now, things you may want to consider looking at to get yourself started is the area that one person occupies, and therefore work out what the theoretical maximum that could fit into a 56 square meters. But then I want you to really sort of go and think outside the box here. Think about other practical considerations. What else happens in a classroom that means it might not be possible to squeeze the maximum number of people in according to the numbers, according to the data. The data will give you one number, that's the maximum that could possibly fit. But in terms of practical considerations, how many do you think could fit in? And I want your discussions with arguments, with calculations, please. Thank you.